Hi everybody, in this video I'd like to talk to you about the unit circle, which is something you may have seen before. And it's called the unit circle because the radius of this particular circle is 1. And we've got our lengths there of this right angled triangle defined as sine theta, which is opposite the angle theta, and cosine theta, which is adjacent to the angle theta. So the cosine there and sine there. So if the length from there to there, from the axis to there, is sine theta, and that length from there to there is cosine theta, then we can define the point P as cosine theta, comma sine theta. It's just the same as if the length here was x and the length here was y, that our point here would be x comma y. So because we've defined our length as cos theta and sine theta, our length is cos theta and sine theta, therefore the point P is defined as cosine theta, sine theta. Okay, another length we can get is a thing called tan theta. Now tan is short for tangent, and you can see here I've got a portion of that unit circle in red, just a portion of it here, and touching the circle at the point S over here, is the tangent line. And you see I've extended it up to a point T, and we've also got a section of the unit circle. So if I just go back to the previous slide, you can see that top right hand section of the unit circle is also shown here as well. So I've got my sine theta and my cosine theta. Now we'll go back to the tan theta bit in a moment, but if you notice here I've got one unit here is called the hypotenuse. One unit there is called the hypotenuse here, and we've got our cosine theta and our sine theta. And Pythagoras' theorem says that the length between P and R squared plus the length of O and OR squared equals the hypotenuse, which is OP squared. Can you see that? PR squared tick plus OR squared tick equals OP squared. So we know that PR is sine theta, and we know that OR is cosine theta, and we know the hypotenuse OP is 1. Therefore sine theta squared plus cosine theta squared equals 1. Now with sine theta squared, let's put that down here, with sine theta squared, we write that in mathematics, instead of writing that, often we write sine squared theta. So please note they are the same thing. So this brings us to our first of our little trig rules here, and that is that sine squared theta plus cosine squared theta equals 1. And if you look at the diagram, you can see how we derive that rule. So please write that rule down. Sine squared theta plus cosine squared theta equals 1. Okay, the next rule I want to talk about on this slide involves tan theta. I mentioned before that tan is short for tangent. There it is there. And it's the length TS. Okay, from T down to S. That is defined as tan theta. If we look at, we've got two right angled triangles here. We've got the triangle that's the larger one with TS, labelled here, TS, and also OS along the bottom there. Also got the triangle which involves the triangle ORP, that's the smaller triangle. So we've got the triangle ORP, the smaller one, and the larger triangle OST. Now the ratio, because these are similar triangles, the ratio of sides here will be the same. That is the ratio between TS and OS, okay, TS over OS, will be the same as the ratio of PR over OR. The ratio of those sides will be the same. And that gives us a formula, of course, that tells us that TS over OS, that ratio there, here it is, equals the ratio of PR over OR. Now going from this line to the next line, what I've done is instead of writing TS, OS, etc., I know that TS is tan theta. Here it is over here. TS is tan theta. I know that OS, in fact that should be, sorry about that, that should be OP. Oh no, that should be OS, sorry, that's right. I know that OS is 1 because it's the radius of the circle. So that's 1 unit there. There it is. I know that PR is sine theta, and I know that OR is cos theta. So therefore I get the rule that tan theta equals sine theta over cos theta. And that's the second important rule that I want you to write down. So there's our two rules. First of all, sine squared theta plus cos squared theta equals 1, and tan theta equals sine theta over cos theta. And those unit circle diagrams can show you how we get both of those really important formulas here and on the previous slide here. Next thing I want to talk about are exact values, and these values are on our formula sheet, information sheet, but we use them so much that eventually, hopefully, you'll commit them to memory so you don't have to look them up all the time. And they involve around a couple of different triangles. There's this first triangle here which has the degrees of 30 and 60. Now we also know that 30 is pi on 6. 30 is pi on 6. Oops, sorry. Now that's pi on 6 there, 30 degrees, pi on 6. And we know that 60 degrees there, that's the same as pi on 3. And we've got some lengths here. We've got 1 to the centre of that triangle is there, and we've also got root 3 as the height of that triangle and 2 as the hypotenuse. Now, given that triangle, and that's the set ratio there for 30 degrees and 60 degrees, or pi on 6 and pi on 3, you can see that using our SOHCAHTOA rules that you would have learnt in previous years, let's remind ourselves of that. SOHCAHTOA. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent. So if we're looking at 30 degrees, our opposite is 1, our hypotenuse is 2. Okay, so remember 1 is opposite 30 degrees and 2 is the hypotenuse there. Okay, so sine theta, sine 30 degrees equals 1 over 2, or sine pi on 6 equals 1 over 2. Sine of 60, if we're looking at 60 degrees, this time our opposite is root 3, our hypotenuse is 2, therefore we get root 3 over 2. Cosine 30, cosine, remember, is adjacent over hypotenuse. So we've got our adjacent being root 3, our hypotenuse being root 2. So cosine 30 is root 3 over 2. Next up, cosine 60. The adjacent for 60 degrees, the one next to the angle, is 1. Our hypotenuse is 2. So cosine 60 or cosine pi on 3 is 1 over 2. Let's look at the tan values. Tan, remember, is opposite over adjacent, and if we look at tan 30, opposite is 1, adjacent is root 3, so we've got 1 over root 3. Now we're just going to digress for a moment and talk about rationalising surds, so I might just pause and go to a new slide just to show you what happens here. It's always good practice to rationalise surds. If you've got 1 over root 3, to rationalise it, you multiply top and bottom by the surd. Okay, so root 3 on root 3. So, on the top now we've got 1 on root 3, which is root 3, over root 3 times root 3, which is 3. So if we rationalise 1 over root 3, we get root 3 on 3. So we can see there that 1 over root 3 is the same as root 3 on 3. Tan 60, if we look at that one, for tan 60 the opposite is root 3, the adjacent is 1, so tan pi on 3 is root 3 on 1, which is just root 3. So there's our exact values for pi on 6 and pi on 3. I'm going to try and use a language of radians rather than degrees, because in all probability in the exam just about every angle is in terms of radians, so we'll get used to that sort of terminology instead of degrees. So there's a summary. Yes, they're on the information sheet, but if you're committed to memory, it's just one less thing you have to look up, which is good. Okay, the other exact values you need to look at are the sine, cos and tan of 45 degrees. Remember, 45 is the same as pi on 4. They're the same sort of thing. So pi on 4 is 45 degrees. For this triangle, it's an isosceles triangle. We've got a right angle in there. We've got 45 degrees there and there. And we've got sides of 1 and a hypotenuse of root 2. And we can work that out via Pythagoras. So that's the standard triangle for 45 degrees or pi on 4 radians. Alright, so now you can look at either 45 here. If you look at this 45 here, the sine ratio, sine is opposite over hypotenuse, so that's 1 over root 2. And if we rationalise 1 over root 2, it's the same as root 2 on 2. There it is there. Cosine 45, okay, if you just look at that one. So there's our angle 45 in there. Cosine is 1 over root 2 as well. And if we rationalise that, we get root 2 on 2. So sine and cosine of pi on 4 is both root 2 on 2. Tan 45, look at that one. There's our degrees 45. Opposite over adjacent, 1 over 1 is 1. So there's our set of standard ratios for 45 degrees or pi on 4. Sine and cosine both root 2 on 2 and tan equals 1. Okay, so in the next video we'll go further into the unit circle and talk about the cast diagram, but that's a bit of an introduction to the unit circle for now.